This is the second lecture on deployment. We're going to talk about vertical consistency. The prior lecture we talked about horizontal consistency. So the vertical consistency problem is that any team can deploy a service at any time. So the blue service in this picture may be deployed assuming certain functionality from the red service, but the new version of the red service hasn't been deployed. So you need to be able to manage such situations. So, and you want to be able to do this without coordinating with the development team because synchronizing the releases is going to cause problems and take time. And the solution is you make the new version of Service A be backward compatible in terms of its interfaces. And then there's a concept called forward compatibility, which also comes into play. So how do you achieve backward compatibility? Well, you allow the APIs to be extended. That is, you can add new APIs, but you never remove an old one. And so what that means is that you have a translation layer where the old API, the external APIs are unchanging, and they get translated into whatever your code base is at that particular time. So the code base will evolve. You may add new APIs or extend the APIs, and then this translation layer is responsible for translating from an old API to the new code base. And that way the client is always guaranteed to find the same interface. Uh, Over time, this can lead to a confusing number of interfaces. I heard a talk by Google where they were going to deprecate a piece of software that they wrote in 2002. Um, it had 105 different APIs, but API 1 still worked. Okay, so this requires a fair amount of discipline on the part of the developers. Uh, so interfaces can be deprecated, but the services that have not been updated will generate errors. Not all services are under active development, so people may not even know that. Developers may ignore messages about deprecating interfaces. You get a lot of mail, and some you read, some you don't. And so the implication of this is you deprecate infrequently and with caution. What about dependent services? That's the ones, the green in that picture, the ones downstream. Uh, the ones that are within your control should maintain backward compatibility. So then, if you've updated you've updated them, but their clients have not been updated. We have exactly the same situation. Dependent services that are not within your control, third-party software and so on, cannot be forced to maintain backward compatibility because it's not inside your control. Well, how do you deal with that? Standard architectural things is you minimize impact of changes by localizing the interactions with the third-party software in a single place, and so that way when you have to change it, you only have to change it once. What does forward compatibility mean? Forward compatibility means that you're going to gracefully handle unknown calls and database schema information. So if your service receives a method call it does not recognize, uh, it doesn't just stop, throw an exception and stop. It returns gracefully and says, I don't recognize this, because the call could be intended for a later version where this method in fact is supporting. Same thing in terms of databases and database tables. So forward compatibility allows a version of a service to be upgraded or rolled back independently from its clients. Okay, back to feature toggles. Feature toggles go across multiple levels of service calls. And so they all should be activated simultaneously. Again, something like Zookeeper or Console is ideally suited for this type of activity. So to summarize vertical consistency, the primary technique is to guarantee backward compatibility, but it also you want to have forward compatibility and be graceful in terms of how you handle errors. And feature toggles will cut across levels of service. And so the feature toggle manager that we talked about last time will manage multiple levels as well as within a single service. Okay, what about data? You have two types of data consistency problems during an upgrade. One is with persistent data and the other is with transient data. So uh, the problem with maintaining consistency between a service and persistent data is when the data schema or semantics of the data change from one version to the next. And you treat this as extending an interface. So at some level, a database schema is an interface to the database, to the data. And so you only extend the schema. You not change the semantics, and that gets you backward compatibility. You treat schema modifications as features to be toggled, and then you can maintain consistency among the various services that access the data. If you really have to change the semantics of the schema, uh, then you would uh, treat it as a backward compatibility problem. And so there would be a translation layer that would translate from the old schema to the new schema. Some database management systems, relational, uh, restructure the data while maintaining access. So in the background, they will be copying the data from the old schema to the new schema. And depending on how you access it, you'll either go through an immediate translation or you will find data that's already been translated. What about transient data? So you may have transient data within an instance of a service. You may be caching for performance reasons. You may be maintaining system state. And if you get a new instance, you need access to this transient data, new version, or even a new instance of an old version. And so you use, again, the coordination manager. This is the type of problem that Zookeeper or Console were designed to solve. The only caveat in this is that you have to maintain at least one instance of a service that uses the coordination manager. Otherwise, the data stored in the coordination manager may be lost. Depends on the particular implementation of the coordination manager. But in general, if you have no clients as a coordination manager, then you kill yourself. So to summarize, vertical consistency is maintained by maintaining backward compatibility and gracefully dealing with errors in terms of forward compatibility. Data consistency is maintained by never changing the schema, or if it has to be changed, then treat it as a backward compatibility problem. And data consistency for transient data is maintained by a coordination manager.